All right, so let's take a look at an example. So in seawater, the concentration of magnesium is that concentration, and then we have the concentration of the calcium as well. And then the question asks, at what pH does the precipitation begin, and what precipitates out, right? And so we're given the KSPs of the two hydroxides, and we know precipitation will occur when Q is equal to K, when Q is equal to K. And so we can write out equations for both of these sides, right? So this KSP is 2.06 times 10 to the negative 13, and it's equal to the concentration of the magnesium 2 plus times the concentration of the hydroxide squared. And then on this other side, we have essentially the same thing, just different numbers, right? So 4.86 times 10 to the negative 6, which is equal to the calcium 2 plus times the concentration of the hydroxide squared, right? And so now we have the initial concentrations already of the magnesium and the calcium, so we can plug both of those into our two equations to determine which one is going to precipitate out first and when. So in this case, what we need to do is plug these numbers in and then solve for our concentration of hydroxide, because that's going to be related to pH. So let's see, on this side we have 2.06 times 10 to the negative 13 is equal to 0.059 times the concentration of hydroxide squared. And then on this other side we have 4.86 times 10 to the negative 6 is equal to 0.011 times the concentration of hydroxide squared. And so now what we can do is solve for both of our concentrations of hydroxides. And so on this left end, this you should get 1.9 times 10 to the negative 6 molar. Whereas on this right side, if you solve for the concentration of hydroxide, you should get 2.1 times 10 to the negative 2. So as we can see, the concentration of the hydroxide required for precipitation for Q to equal to K is much less for the magnesium than it is for the calcium. And so we can answer our first question, and that was that magnesium will precipitate out first. And then the question asks for what pH does this begin at, right? What pH? And so we have the concentration of our hydroxides. If we think to the last chapter, we know that POH is equal to the negative log of the concentration of hydroxide. And so we can take this concentration right here, plug it into right here, solve for our POH. If you plug that in, you should get 5.72. And then we know that 14 is equal to pH plus POH. And so then we can take this 5.72, plug it into our POH, and then solve for a pH of 8.28 as our final answer. So the magnesium hydroxide will begin to precipitate out at a pH of 8.28.